A quiz? Yeah. Mark your own. My favorite student, good old Ann Serkey. Total distance, 45 kilometers. You can almost certainly expect some kind of a distance question on your test. It's a great application of vectors, and it's an easy one for you to visualize. Displacement, well, I see a compass rose. Again, I would get in the habit somewhere at the top of each page, or for me, because I only see a limited amount on my screen next to each question, Kylie, draw that compass rose. It gets rid of, I'm the king of getting east and west mixed up when I'm in a rush. Happens all the time. And you wrote something down, you feel better. So 25 kilometers due south, yoink, plus 20 kilometers due east, yoink. I guess I got a hankering to add those together. Eric, any thoughts on how I could draw them? Tip to tail, you say. And I drew the 20 a little bit shorter. There is the displacement. It's going to be Pythagoras. It's going to be 25 squared plus 20 squared. I don't think this one will work out evenly. 25 squared plus 20 squared square root, or will it? No, 32. Units, kilometers. At. Always, again, common mistakes. Kids find this angle. You go back and you find where the vector is originating from. It's originating from here. Opposite, adjacent. Once again, it's going to be tangent. Have I got room to fit that in here? Sure I do. Tan theta equals opposite over adjacent. Shift tan equals opposite over adjacent. Who's in pre-calc 11? You guys are doing trig. Have you guys started doing radians yet? No? Okay. So your calculators are all still in degrees then. I always have to ask that because physics we use degrees. Degrees, the only thing they're good for is doing math in your head. Everything else, radians, is actually a much better way to measure angles, and you'll learn that in math either this year or next year. Is it 38.6? 38.7? I'll go 39 degrees, but I'll take 38.7. 39 degrees. What of what? North of south, east of west, what of what? Is this south of east or east of south? Okay, this is, start out going south and go east of south. I would also take at 51 degrees south of east. Going to give you 1 mark for the magnitude, half mark for the angle, half mark for the correct what of what. This time I didn't give any marks for the picture. Hopefully I've convinced you, though, trying to do these without drawing a little picture is a little tough. 2 students are pushing a heavy bench, okay? One pushes with a force 255 newtons to the east. One pushes with a force 375 newtons to the north. What's the resultant? Okay. 255, 375, again, by the way, don't write this down. You could have gone north first and then east, and that's how you get that second angle that I always refer to. Adding the order doesn't matter, because 5 plus 3 is the same as 3 plus 5. If you're subtracting vectors, how do we subtract vectors? I add the opposite. But if you're doing that, then the order matters. You better make sure you go the positive one plus the negative one and draw them in that order. Resultant's going to be yoink, and I'll call that F. So F is going to be Pythagoras, 255 squared plus 375 squared, square root. 453? Yes? No? Yeah? 453 units, newtons Now that also looks like north, which is why whenever I want to refer to direction, Noah, I always put an at symbol. That's how I know, oh, the end to the right of that is going to be a north, if there is one, and the end to the left is the unit newtons. Sorry, you only got so many letters in the English language. Theta is going to go right there. Opposite adjacent, tan theta equals 375 over 255. 56 degrees. What of what? North of south, east of west, what of what? This is north of east, or I would also take 90 minus 56, 34 degrees east of north. You got it right, 2 out of 2. Otherwise, same idea. 1 mark for the magnitude, half mark for the theta, half mark for the angle. For the what of what? Turn the page. I like number 3. I like number 3. I like number 3. By the way, Zach, as far as I'm concerned, this is the same question also as an airplane with a crosswind. Boat with a current pushing it sideways, airplane with a crosswind pushing it sideways. It's the same physics. Okay. River flows north. Which way does the river flow? North. You know what? If I'm going to draw the river, then I guess the river is going to look like this, because that way the current can flow north, right? Yeah, think about it a little bit, but the current flows parallel to the river, not from the shore. So heads due west. So the motorboat is doing this. Told you, it's why I draw that compass thing. Doesn't help, mister. Shut up. Okay, motorboat's doing this. And the current is doing that. And they want the resultant. Oh! I think I'm going to add these two together tip to tail. Now remember, I have no problem doing both. In the notes, I gave you the resultant, and we use that to figure out the current and the boat's motor. Here, I'm giving you the boat's motor and the current. We're using that to find the resultant. It's components, or if I give you the slanty, you can find the components. As far as I'm concerned, both of those, totally fair game. It's going to be that plus that. There's the resultant. The resultant is going to be, the velocity is going to be 8.7 squared plus 3.2 squared. Square root. 9.3, 9.27, I'll go 9.3 meters per second. At, so that gets you 1 mark. At, yomp, there's theta, opposite, adjacent. .2, I'll go 20 degrees. What of what? North of south, east of west? What of what? North of west? Or, I guess, 80, Mr. Dueck? Bad math. 60 degrees west of north. By the way, what if you just said northwest and you didn't put a theta? What angle would be northwest exactly? Think about it. 45 degrees. The convention in navigation is if you say northwest, what you're saying is go exactly 45 degrees. Or if you say southeast, you're saying going exactly 45 degrees. Then they do something called north-northwest, which is half of 45 degrees, 22.5 degrees. So this is where in navigation they'll start to talk about things like that. I won't be testing you on any of that, but nerd moment. Isn't the second angle 70 degrees? Like that? Boy, I botched that twice. See what happens when I don't teach for a day? It's scary. Again, mark, 1 mark, half mark, half mark. River is 83 meters wide. Well, 83 meters wide, that's that way. which means I'm going to use a velocity in exactly that direction, the 8.7. So how long does it take? I know that d equals 83. I'll call it dx because it's horizontal. I know vx is 8.7. We've said for the motorboat question, we're going to assume acceleration is 0. T equals, hey, there is an equation that has those in it. It goes like this: d equals vit plus a half at squared. But Jordan, because a is 0, we can say, ha-ha, yes. Oh, and it's actually dx and vx because they're in the same direction. Hey, folks, how would I get the t by itself? I think I'd divide by the v. So it's going to be 83 divided by 8.7. 9.54. You know what? I'll write 9.54. 9.5 I'd take, but since I know I'm going to use this, I'll go a couple extra sig figs. So I'm going to write 9.54 seconds. 1 mark. Direction. It's a trick question. What did we just find? Times a scalar, no direction, right? So don't get vector happy. Energy's a scalar, no direction. Mass, scalar, no direction. Speed, scalar, no direction. What are you saying, Mr. Dueck? On the multiple choice, you might give us a list of things and say which one's a vector, which one's a scalar, circle. Yeah, maybe. Okay. How far down? Oh, now they want downstream. Now, downstream, I think what they're asking for now is that distance. I'll call that dy. Why? Because it's vertical. Why? Okay. Tough audience. Well, Vy is in the same direction, 3.2. I know that time is 9.54. Again, we're assuming the river is steady. It's not a flood suddenly and the river doesn't pick up. So it's going to be dy equals Vyt plus a half at squared. No way! It's going to be 3.2 times 9.54. Do you get 30.5? I'll take 31, but I'll go 30.5 meters. 1 mark. Components. A heavy box is pulled to the right. Yoink. Cross a wooden floor with a rope. Check. The rope makes an angle of 50 degrees with the floor. Better dulp. There's the floor. There's the rope. 50 degrees. Find the horizontal component of the force. Okay. So, it says we're exerting a force of 123 newtons. I'm going to break that up into horizontal and vertical. Opposite, adjacent. They want horizontal, Mr. Dueck? Cos of 50 equals adjacent over hypotenuse. $79? 79.1. I'll go 79 newtons. 1 mark. The vertical component is going to end up being Fy. It's going to be 123 sine 50. Sine, come on, sine 50. Do you get 94.2? I'll take 94 newtons. Number 5, 2 forces act on an object. One force is 85 newtons due west. I've scrolled down. I better draw compass rose, especially after the last question where I started going east. Okay, so it's going to be west. Carly, I got that one right this time. Woohoo! North. Okay, so the resultant force is going to be 8.5 plus a little longer, 12. There's mystery force F. I like that. Square root. 14.7 newtons. I almost wrote meters per second. Newtons at, yoink, there's theta, opposite, adjacent, tan theta equals 12 over 8.5. Uh, 54.6, 55. I'll go 54.7 just to be a bit more accurate, but 55 would work. So 54.7 degrees. What of what? North of south, east of west? What of what? This is north of west. Start out going west, north of west. Same as before, 1 mark, half mark, half mark. Did anybody find the other angle west of north? $35.3. Then B, I said bonus, find the equilibrant force. The equilibrant force is the force that exactly cancels out this one. Here's what we're really saying. You want all three forces to add to 0. How big is the first force? 8.5. How big is the second force? 12. What would 0 displacement look like? Where would I end up? Grant. The equilibrant force is going to look like that. Slightly different. Instead of pointing up and left, like I have here, it's pointing down and right. But do you know how big it's going to be? It's going to be 14.7 newtons, because if I do Pythagoras, I'm going to get the same answer. And if I find this angle here, well, let's see. The short version is this. It's going to be 14.7 newtons at, and it's going to be at an angle of 54.7 degrees, but instead of north of west, south of east. That'll be that's the opposite. That's the negative canceling out force. Or 35.3 degrees east of south. And in fact, I think that's what I would find if I drew the picture. But the shortcut, if you want to cancel out a force, Olivia, it's going to be same magnitude. It's going to be same angle, but north becomes south, west become east, and vice versa. That you're what of what? That's the equilibrant. So if you got that, 2-mark bonus. Since it's bonus, all or nothing. Which means, by the way, I think this quiz is going to be out of 17, but I'll get back to there in a second. I like number 6. I like number 6. I like number 6. Number 6 is a nice question. Number 6 is a challenging question. So a pilot wants to fly directly south. What I've just told you is the resultant. I want everything to end up pointing due south. The wind is blowing 125. You know what? I better draw a compass rose. The wind is blowing 125 kilometers per hour toward the west. Plane is moving with an airspeed of that. At what angle does the pilot have to aim the plane? What we're saying here is this. In terms of the physics, we're saying the engine velocity and the wind velocity gives you the ground velocity. Okay? So far, so good. Well, I know the wind. I know the resultant. Not how big, but I know the direction. I don't know. what the engine velocity is going to look like. How could I get the engine velocity by itself? In this equation, how would I get the engine velocity by itself? Right? How do I subtract vectors? I don't. You know what I'd do instead? Add the opposite. So you ready? Ground velocity. I don't know how big it is, but what direction is it? South. So Justice says, you know what? I'll use a different color. Draw that. I'll call that V ground. Wind velocity to the west. What would negative wind velocity be? Yoink. How big is that? 125. What's the engine velocity? I guess the engine velocity, which now that I think about it makes sense. If the wind is pushing me to the left and I want to go straight down, I better aim down and right. So you may have been able to kind of figure that out. I know some kids, they actually go do this and they can draw the triangle. They can say, well, you know what? I must be going down and to the right to cancel. And if you jump straight to that, great. But if you're looking for a way to get there systematically, Noah, it's a subtraction question. Oh, and that's going to be theta. Oh, and I know the engine velocity. Haha, they told me how fast the engine is moving. 445. That's good. Because now I got two numbers. I can do the trig now, Olivia. So first thing it wants is what angle? There's my theta. See it? Opposite. Haha, hypotenuse, not tangent. Which trig function will I use to find the angle? Cos. Sorry, sine. That's what I said. Thank you. I saw the sign. Anyways, sine. $16.3? Yeah? So, what they wanted was theta, so 16.3 degrees. What of what? North of south, east of west? South of east or east of south? Okay. Remember, the of is always the vertical or horizontal. So the of is south. What of south? Or I would take 76.7 degrees south of east. 74, of course it was. 73, of course it was. For this case, 1 mark for the theta, 1 mark for the what of what. That's a tough question. I totally get that. But to me, that's actually one of the more useful things about vectors. This is what they would actually do. And again, Zach, I'm lying. Nowadays, I imagine it's all done by GPS and computers. But I would still suspect pilots need to learn that because, hey, the computer's acting wonky or whatever. I suspect they have to do something like that, right? B, what's the plane speed relative to the ground? Oh, it's going to be ground squared plus 125 squared equals 445 squared. It's still Pythagoras, but it's not Pythagoras where you're finding the hypotenuse. It's going to end up being 445 squared minus 125 squared, square root. And this is also something, because now this is how the pilot, I'm assuming all of you have flown on a plane at least once. About 5 minutes after you take off, what does the pilot do? Tell you estimated time. Well, there it is. He's using that speed there. His ground speed, he's factored in the wind. It's more complicated because for a long flight, he also has to factor in the rotation of the Earth because the Earth is rotating underneath you. So it's a little more complicated than that, but still, we start out here. 427 kilometers per hour. I guess 2 marks if you got it right. Otherwise, I would give you 1 mark for that and 1 mark for that. So there's the quiz. Can you give yourself a lovely score out of, count 'em, 17, please? So take a quick look at this, please. I call this Vectors Review Assignment. Hey, if you work your way through this, you're in pretty good shape for the test. This is about 80% of your test. Then just start thinking, because there's a multiple choice section, hey, what kind of multiple choice questions can I ask? Probably lots of conceptual stuff and things like that. Okay? I'm going to give you a couple of hints. First of all, this is due same day as test, which for you guys, my block B's is Monday. My block G's, I think it's going to be Tuesday, but I got to double check. There are answers, sort of. If you look on the very, very back, you should find all your answers somewhere in here. You can just kind of, they're scrambled, they're not in the right order, but you should find them on there. Okay? So what's your homework? Well, remember the homework from last day was this velocity vectors and navigation. And then I said if you want some nasties, homework from lesson 3, these lawnmower questions. I gave you a couple, well, 3 lawnmower questions to try. Okay? And then you can work on this vector review assignment. I have nothing else for you. Don't have any cool videos or anything like that. This is going to be, hey, get everything done. On Friday, we'll start lesson 1 of projectiles. Projectiles uses lots of vectors, and it's a good review of free fall and D and V and A. So it's also, I do it in this order deliberately, it's kind of also starting our, holy smokes, we're almost in June. Friday, are we in June? No, still May. Year-end review, we've learned a lot. Okay? Yes? Is lesson 3, is that due for homework, or is that just... Lesson 3 is also due for homework, too. Okay. Yep. Okay.